Hello, everyone. Welcome to the next episode of AWS Meetup Series on YouTube. Today, we have two speakers with us. Dheeraj and Manu both are community builders. They would be taking mini workshops. Dheeraj will be presenting building and deploying Python web application on AWS ECS. Manu will talk about Terraform on AWS. He would also take a small code lab, and the first speaker would be Dheeraj. Dheeraj recently became uh, an AWS hero. Big congrats to you, Dheeraj. Um,
Thank you, Amandeep. So thank you for the introduction and thank you so much for uh, congratulating me for the AWS Hero. Uh, I'm happy to have an opportunity to share my insights and my knowledge to the wider audience of via AWS User Group Punjab. So thank you, Amandeep, and it would be great collaborating with Manu. So uh, that's it from my end before I get started. So Manu, if you want to introduce yourself before we start, so it would be great.
Thank you, Dheeraj. I'm a cloud architect based out of Bangalore. I've been in the IT industry for about 19 years now. Just happy and excited to share my what I have learned in AWS and cloud and other tools surrounding that with the wider audience. Thank you for this opportunity, Amandeep, and I'll be happy to go into the talk. Thank you.
Thanks, Manu. So we'll start with Dheeraj. Dheeraj is basically not only a passionate technical speaker and international tech speaker, a YouTuber, and a technical blogger, but also a very nice human being. He is always ready to help anyone and everyone in the community. Dheeraj, over to you.
Okay, thank you, Amandeep. So let me get started, guys. So let me introduce myself. I am myself Dheeraj Chaudhary. I am having 10 plus years of professional experience into cloud and uh, IT industry. Right now, I'm working as a lead system engineer in EPAM systems. And the agenda for today is we are going to actually deploy deploy and Python web application onto AWS cloud. Now, onto AWS cloud means what? That means that we are going to deploy it onto AWS ECS. So we are going to deploy a containerized application. What that containerized application is going to be? So it is going to be a simple hello world application that I would be creating in front of you, and that application we will go ahead and run on our ECS cluster, and we are going to deploy that by using Terraform. So what exactly we would be focusing in Terraform? We have to make sure that when we have to deploy on AWS ECS, what are the areas that we are going to cover? So let's talk about that. Okay. So guys, here is the pictorial representation of the diagram that of the workshop that we are going to implement today. So what exactly we are going to do is let me zoom a bit so that it will be well visible for you guys. So what we are going to do is we are going to use Terraform, and by using Terraform, we are going to create a containerized application. So the Python app that we are going to create in Flask, that specific app is going to be uh, containerized by using Docker. For example, we would be creating an image out of an image, and we are going to pass our Flask application onto that, and we are going to run that container over here. And after that, we are also going to pass the image that we are going to create out of it and publish it to AWS ECR. Usually we publish it to Docker registry, but in today's uh, uh, use case, we are going to publish it on AWS ECR. Once we publish it on AWS ECR, then we are going to go ahead and start deploying our containerized application onto AWS ECS. So when I'm talking about AWS ECS means under AWS ECS, what we are going to do is first we are going to create a cluster that would be AWS ECS cluster. Under that cluster, we would create a single service that would be ECS service. So this is the code that I would be providing to you. If you want, you can create multiple ECS services also based on your requirement. Now, under the service, ECS service, we are going to create two tasks. And right now, the kind of deployment that we would be doing, we are doing this deployment onto AWS ECS Fargate. We are not going to do it on AWS ECS EC2. So just be aware of that. So the two logos that you see over here, these represents that we the task that we are going to run. Those tasks are going to be on AWS ECS Fargate, and this would be the ECS service. So without wasting much of the time, what I will do, I will jump to our code editor. So mm, okay, so let's start with the simple discussion about the sample app that we have created. So in this, what we have done, we have just imported a Flask, and after importing Flask, we are just going ahead and creating a route out of it, and we are calling it bad. And over here, we are passing the port that is 5000 over here. The same port that we are passing over here. So to containerize this application, what we are doing, we have created a Docker file. As part of this Docker file, we are using an Alpine image. Under that, what we are doing is we are copying our file that is app.py that you see over here on the left hand side, and app folder that we don't have, that is an extra thing, we can remove it if we want. And we have to install the dependency. So when we are going to spin up our container, at that time, to run our specific Python web application, it has to have Flask installed on it. So to do that, we are installing the dependency that is pip install Flask, and we are exposing the port. So we are exposing the port over here, which is port 5000, and you can see the same port I have exposed over here, that is 5000 from the web application perspective also, and the same we have done over here also. Okay, so this is the basic sample application and the Docker file that we would be using to go ahead and deploy that onto AWS ECS. Now, let's move to the Terraform part. Now, if I move to the Terraform part, I would love to first go ahead and talk about the service, the code that we are going to deploy. So in that case, the first and foremost thing, we are going to define our providers. So if you guys are doing it at your place, right now I'm doing it on Windows. That is the reason these are the providers, and I have given the region as US East 2 for this demo. And in versions, I have defined this version file. Don't worry, I'm going to upload this specific code base onto my GitHub repo and share it with you after the session. So these are the basic requirements that I have fulfilled over here. Now, usually as per the best practices, we, if there is any data source, we segregate that into a separate file. If there is a variable, we segregate that into a separate file. We make sure that we have outputs. But as I am doing a demo over here, so I want all of us to be on the same page. That is the reason, instead of segregating the file, which might create confusion, I have kept that into main.tf. But if you are doing this kind of implementation on your production environment, make sure that you segregate it, have it in a structure format, in a tree format that is recommended as per the Terraform best practices. So, so let's get started with the code. So first thing is the data source to get the current AWS account ID. What exactly this specific resource do? So let me just copy this resource. So whenever you are into Terraform, you have to make sure that you use Terraform registry. That is the key uh, towards the development of Terraform. So this is the data source, and right now I'm in AWS registry, and if I search it over here, okay, uh, 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 identity. Maybe it's not able to pick the resource. Actually, it is into Azure. That is the reason it is not picking it. It should be in the AWS provider. And over here, now I should search for it. Okay, AWS. Uh, okay, now I am into providers. Now, resource, Terraform, registry. Ah, so, okay, data source slash. Finally, we got it. So this is the official documentation where you can see that. I will zoom a bit. So over here, what exactly this resource does is it uses the data source. Data source is nothing but which fetches the value at the runtime. So it will fetch the value at the runtime. What exactly it is going to fetch? It is going to fetch your account ID. So it's not only going to fetch your account ID, it is also going to return you further things. And if to know that, what you will have to do is you will have to go to the attributes to understand. So right now, if I go to my code base over here, if you see, by using this identity data source block, wherever I am calling it, I am using the account ID, that is the attribute over here. But in your use case, if you require an ARN, an ID, or a user ID, that is unique identifier of the calling entity, you can do that also by using this specific resource block. Now, as we have discussed about this, now we will discuss about the other resource that we are creating. So if I go back to our diagram, so what we have to do over here is, let's go in a synchronized format, sorry, structured format, one by one, and I have actually structured the code accordingly. So over here we are starting with AWS ECR. So what we are doing in the code, so we are creating a resource that is AWS ECR repository. So this repository is going to be created under ECR repositories, that is Amazon ECR. So when we are going to create our uh, repository for ECR, there would be a my app that we have defined over here. A repository will be created. Okay. Now moving forward, what I have done, after my repository is created, in that repository, the application sample application that I have to containerize that, and I have to push that specific application onto my uh, repository that we have created over here. So to do that, what we are doing is we are creating a null resource. Null resource are usually used to run a provisioners of local exec. What we are doing in this case now, what I have done is I have created an explicit dependency onto AWS ECR repository. So what I have said that till the time AWS ECR repository is not created, we are not going to create this null resource. So once it is created, then that it initializes the creation of this specific resource for us. So after that, this is the triggers for always run. That is a basic parameter. But now let's see the important AWS CLI commands that you should be very well aware of when you're using AWS ECR. So over here in AWS ECR, what exactly we are doing is, you can see there is a first command. What this first command does is it is saying that AWS ECR get login password, and it is providing a username. This configuration, this command that you see over here, what it is going to do is it is going to log in, uh, not login, it is going to authorize you to connect to AWS ECR based on the credentials that you have on your local machines. As you can see, it is local exec, so it will assume that assume your machine is going to have a explicit authorization to AWS ECR. Once it gets the authorization, then we start the process of building the image. So in second command, what exactly we are going to do is we are going to build an image. What this is going to do is this specific command is going to run our Docker file, and this Docker file is going to create an image out of it. Then what we are going to do is we are going to tag that specific image. Once that specific image is tagged, so over here the tag command is as it is. The only change that you should be vouching for is that we are again using the data source and the account ID. So whatever naming convention that we are going to give, that naming convention will start with the account ID and along with these details with it. Okay. Okay. So after that, we will do a Docker push command. What this Docker push command will do, so whatever repository which is going to get created over here, it is going to push that specific image over here, which can be later on utilized by our task that we are going to spin up. So let's go back to our code. So this is what we are going to do as part of a resource, that is the null resources. So just give me 1 minute. So I don't think, okay. So okay, uh, there is one question. I will just answer that question. So Rani has asked me that as part of Terraform best practices, what we need to do. So as part of Terraform best practices, what we need to do, what I was speaking about is whenever you're creating a tree structure for your Terraform, whenever you're creating a tree structure for your Terraform implementation, at that time we create a main.tf file. Usually we modularize our code. We provide create different modules when we are going to do it on the production level. But in our case, we are not doing it in the modularized manner. That is the reason we are keeping the code in main.tf. But as part of Terraform best practices, what exactly what I was talking about, that whenever you are creating a variable, it is recommended that you create a separate variable.tf file and store your variables over there. The same way, so for example, as I have defined the version, I have created a separate version file. I can define this into the main.tf file also. The same for providers. As we are going to use AWS providers, I have defined that under providers file. So what I was saying is, if you want to declare some variables to extend this solution, you can create a variables.tf file. So it will be easy for you to keep a track of the variables that have been created. And apart from that, if you want to check any outputs at the time of running Terraform plan, at that time also you can use outputs.tf file. I hope that answers your question. So now moving forward to the next thing. So whenever we have to implement something or we have to go through something into AWS in terms of AWS implementation, the first and foremost thing which comes into picture is the access, the IAM, right? So over here, then what exactly we will have to do is, after creating this local provisioners and pushing it onto the ECR, we will be moving to the next part. And what that next part is, so we are done with we have dockerized our application, we have pushed it onto ECR, the image has been pushed. Now we will move to AWS ECS. So before moving to AWS ECS, we also have to make sure that we are going to add appropriate permissions. So for that, what we're going to do is we are going to create an IAM role for the ECS task execution that we have to do. So as part of this IAM role, what we are doing is we are creating a trust policy and attaching to it. And as part of this trust policy, it is allowing the STS colon assume role for the ECS task Amazon AWS.com. This will allow us to run the task that we are going to define as part of our last resource into this terraform.tf file. Now, so once we are done with the IAM role creation, what we will have to do is first we will create the ECS cluster. So as part of this ECS cluster creation, we are going to define a resource block where we have given AWS ECS cluster and we have named it as my cluster. Okay. Now, apart from the after cluster creation, it is a hierarchy. Under cluster, we will create an ECS service. How you will understand the hierarchy? Now, if I go to the code block of creating a ECS service, what I'm doing over here is, if you will see, I have given the name and I have referenced to the the cluster which has been created, which is one of the mandatory entry that you have to define when you're creating a service, because service comes under a cluster. So you have to define this. And we have also defined the task definition that we are going to create after this. Okay. And the launch time, instead of EC2, I have kept it as at the current moment, I have kept it as Fargate. So why not, let's go ahead and see what are the different launch types that are being offered as part of AWS service. So data source ECS, this is the AWS service. So if we go in arguments reference, and if I go to cluster, and if I search, see, these are the launch types which are available. That is EC2, Fargate, and external. And if you are not mentioning anything, it is going to default to EC2. But at the current moment, I have mentioned Fargate over here. That's what we're going to use. And apart from this, let's, as we are into this documentation, we can also check that what are the required parameters that are important for this resource to be created. So one is the name. Apart from that, I don't see any other parameters. Okay, so these are some other arguments. If we are using load balancers and something, that if we are using that, we have to define those values. So as per our current implementation, we have defined the name, the cluster, the task definition. Okay, so let's go back, and the launch type. And I have kept the desired count as 0. But if you want to keep the desired count as 3 or 4, so what it will do at the time when you're going to launch this and spin up the cluster, at that time it will automatically create the task, that is a containerized application which is going to run to which the AWS ECS cluster service would be pointing. I have kept it 0. There is a reason for that. The reason for that is sometimes if something breaks, it allows us some time to do that, and later on I can show you on from the AWS console that how we can modify that desired count, and it will automatically spin up the task definitions over there. And last but not the least, we are trying to achieve high availability by specifying the subnet IDs over here. So right now I have segregated this into two subnets. So right now I am in US East. So I am in US East 2. So what I have done is I have kept a one, I am running one container that we have, that is one task into US East 2A, and the another one is US East 2C. If you want to distribute it more, you can keep it in US East 2B also to achieve high availability. But from the implementation perspective, and to showcase that we are implementing a highly available solution, I have distributed that into two availability zones only. So that is what we have defined in the network configuration, that is the subnet IDs. And this subnet IDs I have not created. These are the default subnet IDs which are associated with our default subnet that I have onto my account. Now, moving forward, after that, what we are doing is we are actually creating a task definition. So after creating ECS service, I am creating a task definition where I have given the family, and I have also said that this would I have created a dependency of this onto the null resource. The reason for that is that null resource is going to go ahead and create an ECR repository for us. But apart from creation of ECS repository, we have to also make sure that there is a file which is added into that specific repository, because that is the container image which is going to be picked by the ECS task definition, and it is going to spin up that. So that is the reason I have created a dependency over here. Now, in terms of network mode, I have kept it on VPC network. And again, I have mentioned Fargate over here. So let's see what are the argument offerings that we have as part of the official documentation. So if I go in resources, if I go in argument reference, you can see that container definitions is the required parameter. Family is also a required parameter. Family means you are giving a unique name to the task definition sets that we are creating as part of it. Then the other things are optional that I can see over here, and it has a lot of uh, options or properties arguments that you can define while you are creating this specific resource. So for EFS volume configuration, we have something Docker volume configuration, we have runtime platform authorization config, IAM. So a lot of arguments I can see for this resource. Now coming to attribute reference. So attribute reference, so when you are going to use the data block for this, so once the resource is created for this, if you want to get some return value out of it, so these would be the return value, that would be the ARN without revision tags all. So these are the only four arguments. So let's go back to our code. So over here, what is this execution role ARN? This is the same role that we have created over here. AWS IAM role, ECS execution role. So this permission we are providing to ECS task definition so that it will go ahead and run our containerized task that we can have. Now, moving forward, so we can also mention the CPU that we would require as part of our task or the containers that needs to run. So right now I have kept it minimal because the application that I'm deploying, it is a very small application. So not much load would be there as part of that sample application, that is the hello world. Now, and for from memory perspective also, it is 512. I can reduce that also, but just for a demo purpose I have kept it. So you can define your CPU and memory. So for defining your CPU and memory over here, make sure you check the documentation over here, that what kind of CPU is being used. So many a times when you are if you define 1024 over here as CPU, it might not work. The reason for that is there is a hierarchy which has been defined for the parameters it is going to take. So if you don't find that, what you can do is you can go to AWS console, try to create a task definition over here. So this is repository cluster task definition. So if I create a new task definition, so see, it is one CPU, 5 CPU. So it is minimum 2 GB, or it is minimum 1 GB. So these are the configurations which are defined. So you can take a reference from here, and these are the memory which has been defined. You can take a reference from that also. But because in the official documentation of Terraform, I don't see that. Maybe you might be having that on the AWS official documentation that you have to search for. But that is one point that you have to take care of. Otherwise, the code might fail in terms of the CPU and memory that you are defining over here. Okay. So now after, so this is going to just, so this resource block is sufficient for us to go ahead and create our ECS definition. So under the ECS definition comes the containerization that we are going to define, that is container definitions. So as part of container definition, what we have done is we have defined a JSON code in which I have said that the container name would be my container, and I have given the image as the same name. Okay, it is the same name that I have defined over here as part of Docker push, and that we would be referring over here. And I have done the port mapping. So the container port is 800 and the host port is 800. So what we can do is at the current moment, we can keep it 80 and save it. The same we can do it for this also. And while we are running it, it will automatically align it with the host port, that is 80. So that is all the configuration that we would require for AWS. So as part of the current discussion, what we have covered, what all configurations we have covered, we have created an AWS ECR. After creating the AWS ECR, we created an IAM role that would be required for task definition. Then we started with the AWS ECS cluster creation, where we created one cluster. As part of that specific cluster, we created one AWS ECS service, and under that ECS service, we created two tasks which would be associated. Again, right now the two task is not going to create because we have kept it 0, but later on, once we check if the code is getting deployed successfully, at that moment we will understand that we can go ahead and create the task that we are looking for. So by any chance, if it does not work, please don't mind. Sometimes it works, sometimes it does not work because this is a runtime workshop. But yes, if it does not, I will try to fix the code and send it, upload it on the GitHub repo. But right now, a few minutes before the code that I have tested, it is working and it is functional. Let's go ahead and see. So at the current moment, if I take you to Amazon ECR, you will see that there is no repositories that I have created at the current moment. And if I take you to the clusters, you will see there is no cluster, no namespace, no task definition that has been created. So let's go back to our clusters and let's do some deployment. So what I will do, I will just do a new terminal. I will open a git bash over here. As part of this git bash, I will do terraform init. I hope that is going to be visible. Sorry, the terminal itself. And terminal, that is the bash. Okay, so the terminal is here. So the Terraform initialization was done. What we will do now, I will just run another command, that is terraform format. So it has formatted two files, that is main.tf and providers.tf. Make sure that you run this format command. The reason for that is many a times when you are running your code and when it goes to git repo or at the time of apply, it gives an error if there is any indentation issue. But if you use terraform format, it is going to go ahead and format, it is going to go ahead and remove the indentation issues and align it into the appropriate indented format that terraform tf file looks for the HCL code. Now, as we have done that, let's run terraform plan command to see whether our code is functional or not. So I have run the terraform plan command. Let's see. Fantastic. So our code is going to be functional. Now let's see what is the output of our terraform plan command. Let's go one by one. So we triggered terraform plan. Now, so over here, what it has done first it has gone ahead and created a uh, ECR repository. It is going to go ahead. It has not yet created that. So first it will create a ECR repository as per our architectural diagram we can see. So first it will create a ECR. You can see over here, and ECR it will define the ARN, ID, image, this tag as mutable. These are default values. This is the default value that it has taken. Then the name of the app that we have defined as part of our code. Then the other things it has taken by default. So whenever you see the green plus sign, that means these things are getting added as part of our Terraform implementation, or it is going to get added. That's what it's showing. After creating the repository, it is going to create the ECS cluster. And after creating the ECS cluster, it is going ahead and creating the ECS service. Then it is creating the task definition. And at the end, it is creating the IAM roles, which is going to be associated. So all these things are working as expected. And our code to push over here is also working as expected. So let's do Let me clear the screen once again and let's perform Terraform. Mm, apply auto, sorry, auto. Now this will take some amount of time. We will have to wait for that.
Dheeraj, there is some question in the chat. Would you like to answer that while we are waiting?
Okay. So can you please quickly repeat the steps we have done so far at the high level? Okay. I guess somebody joined late. So let me give an overview to that person. I don't know why that windows. Yes. So what we have done is we have created a containerized application. That application is nothing but our app.py. That is a Flask application. That is a hello world application. After creating that hello world application, what we have done, we have created a Docker file for that application that we are going to containerize. Over there, we have mentioned all the dependencies as well as the commands that we need to run as part of that specific application for app.py. Now, apart from that, we have created a version where we have defined that the Terraform version should be 0.12. We have defined the providers as we are doing it on the Windows machine. And in the main file, we have defined all these services. So we have defined how resource block for creating the AWS ECR. We have defined resource block for creating ECS cluster, ECS service, task definitions, and we have also defined uh, an IAM role that can be assumed from the task definition for spinning up the containers. Now, that is the answer to the first question. Now, the answer to the second question is how close is the example to the production use case? So, for production use case, honestly speaking, at one time when you are doing it, so it can be multiple services. So, usually, if people are using ECS, definitely they might go with the uh, microservices deployment kind of approach where you might deploy your application, different application on to different uh, services under one cluster, and as part of that services you might enable path based routing which might route the traffic to the specific application which has been hosted on the specific service. So that would be the production use case. And if you compare this with the production use case, so this you can see that say that this can be a skeleton that you can use, and upon that you can keep on adding the services and you can keep on adding the task. And as part of the local exec, if you want to add multiple uh, if you want to create multiple images at that time, you can push that image to the ECR and you can utilize that image as part of your different service or different microservices application that you're trying to host. So that would be answer to the last question. Now coming back over here, so I can see the apply command is done. Okay, so let's go back to our clusters and see. Okay, see, my cluster is created, and under my cluster one service is also created. And under this service you can see that we have not deployed any application yet. And over here if I refresh, it has created a private repository also. So just give me 1 minute. Okay. So our cluster is in place, our service is in place. So now let's go ahead and check if we can spin up the task by modifying the service over here. So this is the desired task. So as you can see, I had mentioned uh, in the code over here the desired count as 0. You can keep it, usually it is not kept at 0, it is kept at 2 3 or based on the requirements, but right now I have kept it at 0 to just showcase you that a desired count can be configured later also and previously also. It should not be a problem, but many a times when you do implementation, if you keep it as 0, it helps you to troubleshoot the issue before it is going ahead in a state where your container is just going to spin up and it is stuck. So in that use cases, sometimes your when you use the command that is a destroy command, that will also not work in some use case scenario. So that is the reason we had kept it at 0. Now moving forward, so if I go over here, if I see my container registry, if I see we have an image also as part of it that we have pushed as part of the local exec. So let me go ahead and check once into the task definition once, that which image it is. This task definition, my task 9, and if I see the JSON, you can see it is going to look for this name. And if I go over here and open this, so I guess this will fulfill our purpose. That is, so the image name is accurate. So try to check this, because many a times if it is breaking, this can be one of the reason where your image name mentioned over here does not matches with the image name mentioned over here. So right now my image name is matching. So in this case, what I can do is I can go back to my clusters service, and over here I can update it to 2. Now this might take some while uh, to update and to add the task definitions over here. So I think uh, this might take a good amount of time. So meanwhile, if somebody is having any questions, they can let me know. Otherwise, what I can do is I can just keep on monitoring this. Once it is up and running, then I can come back upon this. Uh, Over to you, Amandeep.
Thanks, Dheeraj. So, if say someone is not proficient with Terraform and is primarily a developer, what would be the best way to deploy an API to AWS? Um, say, if we don't want to use a Lambda, if it is not a serverless service, what would be the best way to deploy it?
So honestly speaking, the best way to deploy it right now, what we are focusing on is on the real-time use case that the industry uses. So trust me, all companies are either using CloudFormation for infrastructure as code, or they are going to use Terraform. I have seen very few companies who are writing their APIs and they are doing those kinds of implementation. So even if you are a beginner into this and you want to work onto the production side, you will have to go through Terraform implementation or CloudFormation implementation.
So one of the doubts that we have seen in code labs is that there are many wrapper solutions which are available around AWS. So we don't have to actually worry about creation of the infrastructure and all. If someone is an application developer, they would use one of the available solutions, and they would be easily able to deploy the application. So, what advantage does one gets, if one is not using a wrapper application, say, say, for example, a serverless platform like um, to deploy an API versus what we are doing right now.
So a wrapper in kind of, are you talking about in terms of modularizing the code or parameterizing the code where you will just pass the parameters and it will automatically deploy your application with the new changes that you're looking for?
That and minimum configurations which the tools provide in order to deploy an application to
Correct.
cloud.
Correct. So right now what we have done is, so this kinds of implementation, these are the modularized application, modularized implementation in Terraform for which modules are being created in the production use case. So as a
Mhm.
user, if you want to implement this, what you have to do is you just go ahead and you create a main.tf file where you will just say that what are the parameters that you want to pass as part of this specific module. There will be a list of variables, a GitHub documentation README file which will tell you that if you have to create two services, uh, add that specific count to the specific variable as part of your main.tf file if you want to spin up that. Apart from that, it will ask you that which is the specific image that you would be referring to. So that is again one parameterization that can be done over there. Apart from that, if there is any required parameters that needs to be changed, so these all things are structured as part of the modularization. And for user, it is just he is going to go pass the variables and he's going to just click on apply. Automatically the ECS cluster for that specific user is going to be created. That is how it works in the production use case.
Cool. Thank you. How are we looking at the deployment right now? Is it still running? You are muted, Dheeraj.
Sorry, yeah, actually it takes time. That is the reason I said if you want we can continue with Manu and I can come back once it is completed.
What is the estimate? What is the time estimate that you think?
So time estimate, sometimes it is done quickly and within 5 minutes, and sometimes it takes a lot of time. So right now it is still showing me as uh, pending. So if I go in my clusters, so see, so it is still showing that it is running. So sometimes it takes time.
Cool.
No control over that.
Sorry, just asking uh, about when this is done.
So when this is done, what you can do is you can use the ARN of the specific my service. What the service will do is, if you go to this configuration over there, if you take the specific ARN and run that specific ARN or any of the specific ARN, what it will do it will open the application for you onto the browser over here. So that is the only thing that is left from our end. So that is how it works.
Cool.
So based on service would be, you can say that service is kind of a load balancer entry which has been created. So when you hit on the service, it will automatically route you to the one of the container which is up and running on which the application is running. So for example, once you can be routed to task one, the container number one, and the second time if you try to again hit that specific service IP address or URL, it will shift you to container two.
Cool. We will probably let it complete, and once you are done, we'll move to
Okay,
Manu.
okay,
We
okay.
can probably have another discussion until then. So
Yes.
basically, as you said, that a production use case usually involves multiple microservices, and they need to interact, and uh, there needs to be a different architecture for that. However, consider a use case that someone has a standalone application and that he wants to deploy an API to AWS, and there are no other APIs that interact in terms of microservices that needs to be interacted. So, would you still recommend following the same solution that we are currently doing in case someone just wants to deploy a single API with multiple endpoints to AWS?
So from API perspective, I have not tried it, so I don't think so. I would have more insights about it.
Okay,
So I will pass over from that
sure,
specific thing instead of
no
providing irrelevant
problem.
information. Yeah.
That's absolutely fine. Um, okay. And another question is that in case we don't want to use an EC2, with the AWS Elastic Container Service, what other options do we have?
So if you don't want to use EC2, so you can use a kind, if you're using on premise, if there are any servers pointing that you have, you can point it to that where you can run this containerized application that is on your on premise, or you can also run it on Fargate. So right now we are running on Fargate. So if it is on EC2, it is very quick, trust me. So you have a EC2 instance defined and you know that what how many containers it is running. But when it is Fargate and you have selected a spot instances, sometimes it takes time for provisioning the spot instances. So right now it has been targeted to be running on spot instances as a workload. Maybe that is the reason it is taking time.
Cool. And what is the minimum configuration that you would recommend using for an EC2 instance for even a simple API?
So if you are doing it on EC2 instance, at that time, what you can do is, so whatever containers that you are going to run, so you have to make sure that your EC2 instance is having that kind of dependencies installed on that specific machine onto which you are going to run the containers, in terms of application dependency or OS dependency or some modules dependency that it would require to run that specific code base over there.
So sorry, my question was like there are various flavors of EC2 machines which are available. So which configuration machine would we like to? So for example, students would normally use a starter EC2.
T2
Uh,
micro.
yes. So what is the recommended EC2 type for this solution that we are currently talking about?
So recommended EC2 type. So for that, what I can say. So if I go to EC2 over here and search for it, EC2, okay, if I click on launch instance, now whenever you are selecting an instance, so it depends on your requirement of the application. So for example, if your application, you want to run your containerization onto Ubuntu, you can select Ubuntu or Amazon or some other kind of operating systems on which you have to host your containerization platform. Apart from that, every application has its own requirement in terms of uh, uh, architecture which would be required for that specific operating system. It can be 32-bit machine also, 64-bit machine also. So those kind of configuration of yours depends on the application that you're going to host or the application that you're going to containerize. Now in terms of the instance type that you were talking about, that what you recommend, it should be T2 micro, T2 small, or T2 large. So this depends on the kind of containers that you're going to run. So for example, suppose if I am taking T2 micro, so in T2 micro, you can see that I have one virtual CPU and 1 GB of memory. So if I am going to host two containers onto that EC2 instance, so my limit is only two containers. So it will be two containers with a memory of, yeah, with a memory of 500 MB and 500 MB that would be required, and the CPU in that case. So there is a limitation on to the instances type that you're selecting. So if while you're planning out before the implementation of ECS onto the EC2 cluster, at that time you have to make sure that how many containers you're going to run, how many containers you're going to host onto that EC2 instance, and based on that you have to define what kind of EC2 instance you would be going up with. So if you think that you are going to run six containers and a replica sets of them onto different ones, so at that case you will have to match the CPU utilization as well as the memory consumption of your containers and define it accordingly.
Sure. And so, would you recommend having a minimum of two instances when we are using ECS, two or more?
Yes, so minimum we will keep two instances, and upon that two instances we can also enable auto scaling. As part of that auto scaling, we can keep the minimum as two, but based on the workload that we have or the user traffic which is coming in, and the capacity that our specific EC2 instance is going to hold. But if you, as we are always using auto scaling in terms of scalability, so you can keep it as minimum 2 and maximum based on the business use case or the traffic which comes in onto a specific application.
Cool. Before we proceed to the next question, let's quickly see the status.
Uh, so I will just reload this. Okay, it is still loading. See.
Sure, sure. Um, so this um, would once this gets deployed, would this be like public facing, or would it still be
So,
internal to
so,
AWS
so
vendor?
right now I have kept it at public facing. So if you see the default VPC on which I'm deploying it, this default VPC, if I go into VPC and the subnets onto which it is deployed, so those subnets are associated with Internet Gateway and it is having a public access. So if I click on subnets, so these are the two subnets on which we have deployed the task. And if I open the subnet, you can see that a route table has been associated to that. And if I open that route table, you will be able to see the entry of the internet gateway, which opens up the traffic for uh, to make it global, or anyone outside the private network also can use it.
Cool. And I believe that the default exposure would be HTTP and not HTTPS.
So right now I have kept it as HTTP, but if you want, you can keep it as HTTPS, and you can change your port mapping for accessing your application, and you can also attach an ACM as part of your service implementation.
Okay. Can you please come again about the HTTPS part? Would it be like, so my understanding is that once you have to deploy an application on EC2, we have to like manually configure HTTPS certificate for that. Is that right?
Yes. So there is one service in AWS, that is ACM, Certificate Manager. So you can use that service, and if you have open source certificate that you want to attach to the load balancer as part of your service cluster, you can use that. If not, then you can use a private one also. And based on that, you can also enable the traffic inbound and outbound, okay, in terms of your security group or knuckles. And apart from that, you have to make sure that you mention a port 443 that should be open to pass your traffic through and fro.
Cool. And would this configuration go in Terraform?
No, this kinds of configuration is the networking landscape configuration that we so for example, so right now we are just deploying one application onto ECS service, right? But it has been deployed onto a subnet, it has been deployed onto a VPC. So the kind of network thing that we are talking about, it is going to be controlled over there in terms of security group NACL onto the subnet side, and onto the VPC side, if it is a private subnet, onto the custom route table side. But if you talk in terms of Terraform, as I said, we would be defining that onto our Docker file that we have, or we can open that specific port onto our application that we have where we have defined the port, and while we are running the container at that time also. So in if I go in task definition, you have an option of defining the port over here. Mhm. This is task definition, task. So uh, so if I go in task definition one again, create new task definition, it will allow you to provide, see, the ports over here also. If you are doing from AWS console, the same way we have defined in the Terraform uh, file. I think we have a question from Hardeep. So that the question is, so Dheeraj, so what will be your thoughts about auto scaling in this case? So when it is Fargate, you don't have to worry about auto scaling. It will be there will be automatic scaling as it is a managed service. But when it is EC2 instance, you will have to make sure that as whenever we are hosting it on EC2 instance, that means it is a AWS ECS EC2 managed cluster. I mean, where we are going to manage the resource capacity over there, we are going to manage uh, the auto scaling over there. We are going to manage the triggers for auto scaling over there. That would be from our end. But from for Fargate end, everything is managed from their end. So in case of EC2 instance, it will be required, but in case of Fargate, it won't be required.
Cool.
I think there is some issue. It is not giving logs also. Otherwise, I would have checked it. It's not able to run the task. It is just spinning and stopping. Okay, I think there is some authentication issue which is coming in, but I don't think so. There should be an authentication issue. The reason for that is we are already authenticating by using the official uh, command, that is ECR get login and password. This authenticates us for the ECR repository, and the other is the Docker push command, which have actually worked appropriately. So I think this needs to be worked upon. Uh, Amandeep, I'm sorry
Sure.
about that, but I was not getting this error. And I will tell you, this error is coming for ECR. So this error usually comes, and the resolution for that error would be for sorting out your ECR login, or sorting out your credentials in terms of fetching the data from ECR. So right now, I think we have the permissions also, but still it is not able to. So maybe I will have to check that what is the permission which has been missing. But from the code perspective, implementation perspective, this should work. The only thing is some changes at the permission level would be required, to be honest.
Sure. So this is quite normal in live code labs. So
Yes,
nothing
yes.
to worry
So,
about, Dheeraj.
so in live code, what we do actually, there is on, credential tokens or something which has been created, or a KMS key. So those
Mhm.
keys are being stored in SSM parameter, and it has been directly, fetched from the SSM parameter at runtime and done. But right now for local account, we have to pass everything again and again. But in terms of production use case, everything is stored into an encrypted format, and you take it from there and you use it based on your requirement.
Right, right. So yeah, no problem. In we can. Do you want to? Do you have more content, or should we like call it a session?
No, I don't have any more content to share. So I
Cool.
think I am good for that. And meanwhile, we will start the next session. Let me try to add some permission and see if it works out for us
Awesome,
before
awesome.
before we end the
Thanks.
session.
Sure, sure. Thanks, Dheeraj. So let's continue now. And Manu is our next speaker. He is also an AWS community builder, and he is also going to present a mini code lab. Over to you, Manu.
Hi, Amandeep. So, welcome everyone to my talk on Terraform and CI/CD within AWS. The talk by Dheeraj that just we had now, it was very good. I thought he went into a lot of details about ECS and how it is very useful to run the applications on ECS using AWS. It was a lot of information. I also learned a lot of new stuff in there. So thanks for that, Dheeraj. So we can start with my session now. I will share my screen. I hope everyone can see my screen now.
Yes.
Okay. So in this today's talk, I'm going to be talking about Terraform and how CI/CD can be achieved within AWS. This talk. I have imagined it like an L100 type of talk for like absolute beginners. Even if you are like a beginner to AWS and the whole DevOps CI/CD culture, I'm trying to give some information here. So in today's agenda, what we'll be trying to do is We'll be talking about infrastructure as code, and we'll be doing a demo with Terraform here. And we'll be talking about CI/CD, and we'll be using GitHub Actions for doing the CI/CD here in this today's demo. About myself, I've been in the IT industry for about 19 years now. For the last 6 years or so, I've been working as a cloud architect. I'm a AWS cloud community builder. It's very exciting for me to share things I learned in AWS and this DevOps world with a wider audience, because I myself started with in a different, very different type of technology stack, like an ERP stack, and I was able to change my portfolio to completely to cloud. So I feel like if I can do it, you should be able to do that too. So I think that that's the image that I'm coming here with. So let's start in a little bit in the past. So in the beginning, many years back, how we used to do the deployment of any application or code, it was, today we call it click ops, because there was a lot of clicking and typing of commands manually and everything. I remember myself, like I would build some code and I would put it into a VCS or version control repository, and I would feel very good about myself because version control seems like the edge of cutting edge technology at that time. But to bring that code from the repository into the production environment, it took a lot of days or even weeks, because things were done manually. They would have to bring the code there, they would have to manually create the instance, then they would have to install the dependencies and do other things to make it ready, and then create all the network architecture to make it accessible and all those things. So, but today we are in a world of DevOps. So, what's the difference between this all ClickOps and DevOps? So, there's a picture here. This is me waiting for the deployment in a world without DevOps. It's very slow. In the old manual process, it's very slow. I know that in many projects today and many organizations today, even today, they are using manual process. I've seen that in some ERP projects myself. But DevOps, the culture itself brings a lot of automation. So it's very fast and efficient. We could say that the ClickOps kind of way, the manual way, is simple to do. You just do you can go to the AWS console, click here, click there, create the EC2 instance, very simple. And if you have to do it through DevOps, through some tool like infrastructure as code, may not be as simple. You have to learn the Terraform, you need to understand how it interacts with the AWS, all those things. Maybe it's not simple, but there is a lot of overriding benefits for using the tools of DevOps here. Like the ClickOps way, the manual way is not scalable. You can create one application server in a day, maybe, but what if you have to like create a fleet of application servers? It's going to take a week or something. In today's world of Web 2 and Web 3 and all, it's not acceptable to have that kind of delay. This DevOps, as we know today, it's not just the tools that we will be discussing in this talk today. It's also the philosophy that the dev team and the operations team should be very integrated and working together to make things happen. It's also the practice of things like continuous integration, continuous deployment, and of course the tools like Jenkins, GitHub Actions, GitHub, Terraform, etc., which make this philosophy and practice into reality. Looking a little bit deeper into this CI/CD concept, what is CI/CD? CI stands for continuous integration, wherein once the developer has created his code and he has tested out his unit on done his unit tests and he has put it into a repository, we should be able to continuously build that deployable package from that and do some kind of testing on that. And if we have to merge some code from production, we should be able to do that and create the production deployable that package from that change of code. That code, whenever there's a code change, continuously we should be able to create that deployable package. That's what meant by continuous integration. And CD can be of two types. One is continuous delivery, wherein we just take this deployable package and I just put it into a repository like ECR or Docker Hub or some other repository. That's continuous delivery. We don't do anything more than that. There may be a manual step to actually bring that package from the repository into actual production environment. Now, coming to continuous deployment, this is like a complete automated way of doing things, wherein once the package has been released to the repository like JFrog or Artifactory or ECR or Docker Hub, we can automatically pull that latest version and deploy to production. Now you might think that if you do it like this, isn't there a chance of getting a lot of errors or issues? What if somebody puts a wrong code in there and somehow it passes test and the production comes down, right? That's the biggest nightmare that we have. But if you have a robust process in continuous integration and continuous deployment and use the proper procedures, we should be able to do what somebody like Netflix has done today. Netflix is like one of the leaders in this field. They are able to do around 20,000 code deployments in a day. That's like almost 14 in a second or something. It's too many. Like once the code change has been done by a developer, it's able to come to the production so fast. How do we do that? There are things like automation. Automate every step so that once the code change is made, it becomes a deployable package, it gets tested for security things, it gets tested for performance things, and then you can immediately deploy into the production. And if there is an issue, what do we do if there's an issue? So in CI/CD, we have rollback and recovery options as well. Like we have today, GitOps is one methodology that we have. We have blue green deployment, canary deployment. All these things allow you to have a safety mechanism. If there is an issue in the production, you can roll back the code and you can recover from the last working code. So it happens very fast and it happens automated way. So it's a very foolproof system. And security, of course, security is very paramount importance today. And CI/CD pipeline today gives you the ability to test for security issues before it reaches production. Previously, we used to do it like it reaches some instance, some environment, and then the security team will do their own analysis. They come up with issues, we get tickets, we fix them. It goes in a loop like that. But today we have what we call as DevSecOps or shift left, where what we have done is we have taken that security analysis from the last step somewhere left, somewhere inside the pipeline, so that it happens as part of the testing. So the code is very secure now. We can check for vulnerabilities, we can check for any credentials left in the code, those kind of things we can do. So all these things that we have talked about, it gives you the ability to have continuous feedback and continuous improvement of your application. So when the application as it is going through, you can see if the performance is decreasing, are there bottlenecks in your application, are there more issues coming in some parts of your application, all those kind of things you can check and you can have continuous feedback and improvement. Now let's talk about the tools and different areas of DevOps. And I have divided this into a CI area and a CD area, although there might be some overlap between these tools in what they do. So first, of course, we have the source code repository, wherein user is going to check in their code. So we have products like GitHub, GitLab, Bitbucket, etc. in this area. Once the code is there in that, so next step is to create the deployable package out of that or build the code. So we have tools like Jenkins, GitHub Actions, GitLab CI/CD. All these tools are there in this area where it can take that source code and create a deployable package from that, maybe a jar file, maybe a Docker image, something like that. Now, one thing to note here is that these build automation tools, even though I have put them in CI, but with the help of some scripting and plugins, they could also be able to do CD, that is deploying into the production environment. Next step is to test it. So we can use JUnit, Selenium, PyTest. These are just some examples of testing automation within the CI/CD. Then, of course, we have the security, which we call as DevSecOps. We have tools like SonarQube, which can check for code quality, vulnerabilities, etc. This is called a static code analysis tool. And then we have a dynamic code analysis tool, which is going to run the code and check for any security issues. One example is OWASP SAP. Then we have stuff like Trufflehawk, which can look for your code and analysis if to see if there is any secret information that has been left in the code. So today we know that we are not supposed to check in any database passwords or something inside your source code and check it into the GitHub. So if you have Trufflehawk like a tool like that, it could see that as you do the pull request and it will block that. So it will not go into the repository, you can block that. So now we have the deployable package, we tested it, it's secure, everything is good. We can put that into an artifact repository. We have things like JFrog is there, Sonatype is there, Code Artifact is an AWS product. So these are the places where we would keep the executable deployable package. In today's demo, we are going to use ECR because we are going to create a Docker image. So Docker image could go in Code Artifact or it could go in Docker Hub. It can go into ECR. So inside AWS, we have ECR. So that's what we are going to use today. The next step is infrastructure as code. So in today's world, this target environment where we have to deploy the code, it may not even exist when the code has been pushed. So tools like Terraform, Puppet, Chef, CloudFormation, this will allow you to create that target instance or update that environment as required. There are many benefits for using infrastructure as code rather than doing it manually. So we'll come to that. In today's demo, we are going to look at Terraform especially. Then comes the release management. Release management is a methodology which looks at things like, say, I deployed my package to production, but now we have an issue in production which did not come anywhere else. What do we do? How can we roll back to the previous working code? Or things like you have different environments and you want to have different setup for each environment and you want to manage the deployment for different environments. So these kind of things can be managed by a little bit more complex tools like Spinnaker and Argo. They come with tools like blue-green deployment, canary deployment, rollback, those kind of things. So these will allow you to have a better and more robust way of doing your deployment into production. So now my application is in production and it's running. Our job doesn't stop here. We need to observe the code to see is the application performing as expected. So we can use tools like Prometheus, Grafana, ELK Stack, Splunk, etc. to check the metrics, the logs and traces of the application running in production to see if there are any issues. I remember in old days when we used to get an issue in production, it was damn near difficult to find out what really might have happened. You may not get the logs from production. You might have to go through multiple levels of approval to get any at least read access to production. That kind of stuff was there. But today we have, because of these tools, what happens is that I get a P1 issue in production. I can go to Splunk, query for issue, and I can see what might have happened from the tracers and metrics that are there in that tool. So that gives you the observability into your application. So there is a whole lot of tools you can see there's a life cycle here from the time the code gets into the repository to where we are observing it as it is running. So these tools make up the CI and CD tools. In today's demo, we are going to use GitHub as the repository. We are going to do the CI and CD using GitHub Actions. We are going to use ECR as the artifact repository. Now we'll go a little bit deep into the Terraform and infrastructure as code itself. So there are two types of tools for infrastructure as code. One is configuration management tools, which are used to install and manage software on existing infrastructure. These are tools like Chef, Puppet, Ansible, etc. Now you might think that, hey, I used Ansible to create a EC2 instance. So it is possible. So all these tools, they have some overlap between each other, but some tools are suited for one purpose and some tools are suited for another purpose. So this Chef, Puppet, Ansible, etc. These allow you to manage and install software on existing infrastructure. That's where the strength is. And the tools like Terraform, Pulumi, and cloud vendor specific tools like AWS Cloud Formation, these are orchestration tools which is better suited for provisioning the new infrastructure or making changes to that infrastructure. Why should we use infrastructure as code? It gives you the reproducibility. Every time you run it, it's the same result. It is idempotent. It's not going to create one more if there was already existing there. It is scalable. You want to create one instance, you want to create 100 instances. The change in the code or effort is very minimal, unlike a manual way. You can automate it, you can put it into scripts, you can put it into some workflow, you can do all sorts of automation with it, you can test it. You can test it and see if the results are fine and then replicate that in production instead of just doing it manually and praying to gods. We can do collaboration with other teams like a dev team and an ops team. They can collaborate and create infrastructure as code. One team might create the dev portion of it, one team might create the production portion of it. So all those kinds of things are there. Change management, of course, because now the infrastructure is code. So that means it's checked into GitHub as a code. So we can see different versions. We can see if there's a change, where the change occurred, what is the impact of that change. All those things we can see. Now we'll go into Terraform concepts as such. I will be showing the demo just after this. So Terraform concepts, first we have something called a provider. The provider is a plugin that gives you integration with an infra provider. So AWS is a provider, which means using that provider, I can create infra on AWS. Similar to that, there is a Azure provider, Google provider, many others like that. Next thing is a resource. Resource is an infra resource the Terraform is going to provision for me. For example, an AWS instance is a resource. So once you create that instance through Terraform, it's going to manage that. So it's going to see if there are changes to that, it's going to replace that. We can have inputs and outputs. Inputs are the input variables and outputs are output variables. So say we create a EC2 instance and I want to know what is the output, the public IP for that. I don't need to really go into the AWS console to see it. I can use an output variable inside Terraform to see what is that value. Input variables are things like you want to read some value from a file, which gives you some tag values or something, some requirement is there. You want to read a tag value from a file and use that. So that's where you would use the inputs. And locals are local variables. So you want to create some local values at runtime, which are not available before it runs. So you can use locals here. And the other thing is data. So data is like a query. Say you are creating an EC2 instance in Terraform, and you want to know, you don't want to hard code what an image ID or subnet or something. You don't want to hard code that, you want to fetch it at runtime. So what you can do is that you can have a data. So this data portion is going to query the EC2 and tell you what are the values that are existing there, and you can pick a value from there. Now, at this point, I will stop and we will go into the demo. Let me share my screen once again. Is this okay?
Yes.
So here I have, I'll be sharing all this code with you. I have different levels of Terraform code. This is the most simple one that I could think of. Here we have an EC2 instance. We are just creating an EC2 instance, that's all. So this is like the most simple one that we could have. So here we have what is called a provider. So we are saying that we are going to do this in AWS. And Terraform is going to pull the AWS plugin to do that. And then we are saying that the resource that we want to create is a EC2 instance. And this instance is a name that's used inside Terraform. This is you can say it's a variable name. So this name would be only known to Terraform. It's just a variable name. So I'm going to create a EC2 instance here. I'm giving an AMI ID here, and I'm saying this is the instance type I want, and I want to give it a name tag also. So this is a simple one. So before this, what I have things I have done is that I have installed the Terraform. You can check the Terraform site to see what is the specific command you have to do for your specific OS. So in this one, I installed the Terraform. The second step that I did is to set up the AWS CLI in this machine and configure my AWS keys the to get the access to the AWS from the Terraform. So there are multiple ways of getting access from Terraform to AWS. So the simplest one that I could use is to that's access key and secure access key what you have in AWS for a user. You could set those values here, and once you have set those values here, it's available to Terraform and it's able to connect to the Terraform. Sorry, to the AWS. So first step that we had to do is Terraform init. When we do Terraform init, what it's going to do is that it's going to initialize the backend, which is like a database of all the values in Terraform. Then it's going to get all the provider plugins. So here we needed the AWS provider. So it has pulled that AWS provider, and it has created some hidden files here, which contain that state of Terraform. So it says Terraform is successfully initialized. Now we are ready to go for the next step, which is Terraform plan. What plan is going to do is it's going to take this configuration file, and it's going to plan how it's going to deploy. See, we might want to create multiple resources. Some may have dependency with one another. So all those things it's going to plan and come up with a plan for deployment here. So at this step, we will know if it's going to work or not, because it's going to check for AWS CLI and whether it's able to access to AWS from Terraform. Meanwhile, let me also log into the AWS console. So here I have one admin user. This admin user has a credentials are there. He has access keys, so we can create the access key and use those access keys for this particular Terraform run. So we come back to this. So it has created the plan. So it's saying that it will create a EC2 instance here with AMI, and all these other values it's going to know only after it has done it. So we only pass two values, instance type and AMI type. And it's going to add this tag here. So there is one resource that's going to add, and there is nothing is going to destroy or change. So the thing is that whenever you run Terraform plan, it will do the CRUD operations, create, replace, update, and delete. So all these things it will do. So it will tell you about changes, it will tell you about destroying or deleting stuff, or it will tell you about creating stuff. So now we can run the Terraform apply. But it is going to wait for an approval from me by default. Like Dheeraj was showing in the previous session, we can give the auto approve option to that command so that it doesn't wait for your input for creating it. So now it's creating this instance. It might take a couple of minutes or so to create the instance.
Meanwhile, Dheeraj, Manu, would you like to repeat the steps that we have done so far conceptually?
So the steps here are first in a plain machine that you have, first you would install the Terraform. the Terraform CLI would be installed. Secondly, you should install the AWS CLI and then configure that AWS CLI with the access key and secure access key from your user that has access to create the EC2 instances. So once these steps are done, you are ready to start creating the Terraform configuration files. You create the Terraform TF file, you run Terraform init. That Terraform init is going to initialize it. Then you run Terraform plan, which will plan the deployment. Then finally, you will run the Terraform apply, which is going to apply that plan and create the instance here.
Thanks, Manu.
Let's look at this EC2. Simon, the used one, and this is the instance that was we have created from Terraform. It will take some time to initialize and stuff. So this was a very simple example of Terraform. I have other examples which we may not be able to cover in this, but I will be giving all this code to you. So this was another example that I would like to show you. Let me. This is like a bit of production level. This is a bit advanced level of how the Terraform code would look in an actual enterprise scenario. So here we have modularized the code. That's one thing. And we have separated out, we have outputs and variables to make things more dynamic as it goes. So this was our EC2 instance file that we were creating it. This is the file that was we have used to create the EC2 instance. So, but here there are more stuff here. So one thing here is this data I talked about. Data allows you to query the provider to get some value. So here, instead of giving an AWS availability zone directly to the Terraform, I am querying for what are the available AWS availability zones. So this would query the AWS and give me availability zone, which I would be passing into the Terraform configuration file. And this Terraform file has two modules. Modules are what we use to modularize code for different environments within Terraform. So now I have a dev module and I have a QA module, two different environments I'm going to create here. So for the module for dev, I'm saying that it's going to come from that dev folder. And for QA, it's going to come from this QA folder. And here I'm also using a variable name. So like you remember we talked about variable name. So we want to have like some local variable passed to the Terraform and not put it directly inside that. So we can use this kind of variable. So this variable is called, I have defined a variable here. There it has a default value and you can change it. And later on what we can do is that we can refer to it by using var.project name. So project name was the variable name. So we can refer to it using var.project name. So inside here, I have the actual EC2 file that's going to create the EC2 instance. So here, like previously, we have AMI ID, instance type we have. But like you see, the project name is going to come from a variable. So var.project name. And the environment name also, we are fetching from a variable called environment. And there's a name tag that we are going to apply to it. It's going to come from a local variable. How do we create that local variable? This is how we create the local variable. So local variable, we are saying that it has to be a concatenation of project name dash environment. So it's going to come like my project dash dev or my project dash QA. So just like we have in the programming languages. So here you have local variables, you have output variables and input variables. So here, these are the outputs from this. So we're going to output the public IP. So like you saw here, we created an AWS instance of the name instance. So here we can come and say, I want to get the AWS instance dot instance. This will go to that particular instance that was created from this configuration file and get that particular public IP. So when we run this TF file, it's going to look for it's going to create that particular, it's going to output that particular public IP to you. So that way we can know that what is the public IP for the EC2 instance rather than going into the Terraform or going into the AWS AWS console to see what's the values. Amandeep, just one question till what time we have scheduled? 1:30, right?
Yeah, but we can stretch if you want.
Okay.
There is one question in the chat. Um, this use case, does different environments represent different EC2 instances, like the dev and stage that you were showing earlier?
Uh-huh. I'm not able to see the question. Could you repeat that?
Sure. So you were just showing us a production use case wherein we have a dev environment, a dev module and a production module or a QA module. So does that represent different EC2 instances, or is it the same EC2 instances having different deployments? I believe that's the question. Rani, correct me if I'm wrong.
Those will be two different instances. So when this will create one instance, like we have this name tag, it will have the name tag like my project dash dev, and this would create another EC2 instance, and it would have the name like uh, my project dash QA. So that will be two different instances.
Cool. Thank you. Rani, hope that answers your question.
So let's go a little bit forward here. So these are the steps that I talked about now. So install the Terraform as per the operating system, and AWS credentials should be available in the environment. Then you do Terraform init to initialize, Terraform plan, that would plan the deployment. Then you do Terraform apply, that would create the all the infrastructure. And the last thing is Terraform destroy, that we did not do here. So Terraform destroy is what is a command that will destroy the or pull down the infrastructure that we have done. So again, when you do that, it's going to ask me for an approval. It's going to tell you what it's going to destroy. So it will go into the state and check what did we create. So it's going to the instance and seeing that we created this particular instance with a root volume and everything. It's getting all those values, security ID, group, this is the IP and everything. It has gone to the AWS and got all this instant data, and it's asking, do you want to destroy it? So I'm saying, yes, I want to destroy that. So this is the last step, like Terraform destroy. If you want to destroy the infra that you created, you can run this. In case of AWS, if you're trying out something, it's always better to destroy it rather than let it keep there and you get a surprising bill next week. It's never a great situation. So it will destroy it. It's destroying those EC2 instances. So destroy is complete. One resource has been destroyed here. I go into the instance and I can refresh this. It's not there anymore. So it has been destroyed now. It has been terminated. So that's the intro for Terraform, and I have added this link here, where we have all the example code and some more details about how Terraform, other some more advanced details about Terraform, like how to handle secure data within Terraform and that kind of things. So you can refer to this and you can get some more details on that. So I would go to next topic, because I would like to cover the GitHub Actions as well. So recently Terraform Cloud has come out. Uh, Terraform Cloud is an enterprise product from Terraform. What's the difference between Terraform Cloud and what we saw now? So if you look at how we ran Terraform, I just pulled the code from the GitHub, I ran it. The Terraform state is on my local system. So I am an only developer running that code, it's fine. But imagine that your team has, say, 10 to 20 developers who are all pulling this code and running it from their system and all those things. There are a number of issues with this approach, right? So one is that everybody has their own state saved in their local system. That's one thing. And secondly, these AWS credentials that we have, if we had stored there, that also is there on everybody's local system. So this produces a lot of security issues and such. And if we have to use variables and such, that provides even more problems on how this would be run. So Terraform Cloud aims to solve these problems. Terraform Cloud, the main difference is that it runs on cloud. It does not run specifically on your local machine. So the state that we saw the Terraform was saving here, when we ran it, it saved, it started, it created this folder and it created this hidden files here, Terraform state. This is the state that Terraform is creating. So where it has all the data related to what it is created, what it has destroyed, and everything. So what all this data, instead of saving it locally, it would be saved in a Cloud S3 bucket. And second thing is that any variables or credentials that you want to run this Terraform, you don't need to save it locally. It would be saved in the cloud. It could be at an organization level. Maybe you are using one account, or it could be at different repository levels, wherein you want to use different users for different repositories, because you don't want to expose the whole AWS service to everybody, right? So you might have different users for different teams. So they can all use different credentials in the cloud. So, and it's a web console mainly. So you can see all the Terraform running, planning, everything. You can see it on the web console, and also gives you the ability to automate the Terraform running with source code repos. So you can link a source code repo with a Terraform code. What would happen is that when somebody makes a pull request, it's going to automatically run a plan and see are there any changes to the AWS cost. And then only when the code gets pushed and merged into the main repository, only then it will run the apply. So that's a control mechanism that we would want in an enterprise level. We don't want to just run the apply every time. It should only apply when somebody has reviewed the pull request and has approved it to merge, right? So that's how it would be happening in an enterprise level. So that's another thing that we can do with Terraform Cloud. Terraform had some changes in this month of August, which has been a discussion all over the world. Like Terraform has changed from open source to available source, and there's a new tool called OpenTF, which is an open source fork of Terraform. Basically, what happened is that Terraform, when it's open source, everybody can contribute to the open source code, but Terraform, as a company, they were feeling like people are taking undue advantage of this, and because there are a lot of vendors in the industry in this IA in the area, like Pulumi is there, and many Airlift, many other companies are there which work here. So they felt like people were taking undue advantage of this open source model. So they have moved to a different license where you cannot make a change to the Terraform source code and sell it as a different product. So somebody has come up with an OpenTF, which is a open source fork of Terraform. It's just happened this last week. So this is just something that we will have to look at and see what would happen on top of that. So before we go into GitHub Actions, any other questions or anything?
No questions so far, Manu.
Let's go to GitHub Actions. So GitHub Actions is a CI/CD tool from GitHub itself. So you go to the GitHub console and you can enable it from there. Then you have to give the GitHub Actions access to the AWS. How you do that is you have to create an OpenID Connect identity provider and a role inside AWS for the GitHub Actions to use, and that would give access for the GitHub Actions to do any kind of activity inside the AWS. Once these steps are in place, then you can go and create a workflow under the GitHub slash workflows folder. So let's just see that on the screen. Let me go to the GitHub. This repository also I am sharing with this presentation. So this is my example repo for GitHub Actions. So here you should go into settings, actions, general settings. So here you can put you can first you need to allow all actions and reusable workflows, or you can say that only actions from my repository should be run. So you can check here and allow the GitHub to run actions to run. You can specify what permissions would be given to this workflow. So for demo purpose, we have given read and write permissions, which allows the workflow to even make changes to the GitHub repo where it is running. Say, for example, when my workflow is running, I want it to create a pull request automatically. So for doing that, it should have a read and write permission. Or if you don't want to do such thing, you can even go with read access. So all these options you set here, once you have set this, your GitHub Actions is able to run here. So the next step is to give access in AWS to the GitHub Actions. How we do that? We go to IAM. So in IAM, first we create what is called an identity provider. So this is my identity provider. There is a AWS blog about how all the steps that you have to do for creating this. I have added the link to this in the presentation as well. So you create this identity provider. So what is really happening here is you can compare it to how you would try to log into a site with Google. Say you are trying to log into some web application, and it's asking, do you want to log in with Google slash Facebook slash LinkedIn something? Then you select Google. Then you will log into Google. What happening is that Google is going to give you a token. The token will be used by the other server to get the information about this user, and that would be used to get you to log into the actual application. So here also the same kind of thing happens. So the identity provider here is GitHub. So this is the identity provider for GitHub. What is happening in the background is when the GitHub action runs and it tries to access the AWS, what is happening in the background is AWS will ask the GitHub access, hey, do you want to log in using this identity provider, which is GitHub? So then the workflow would say yes. So it would give that identity token and access token from GitHub. So these two tokens would be used by the AWS to give a specific role to the GitHub Actions. So that's what happens here. So just like you log into the web application with Google or Facebook or LinkedIn, same kind of thing happens here. The GitHub Actions is logging into AWS using the ID from GitHub. So I create this identity provider. Then I have to create a policy. Let me go to the role. So this is my role. This is the role that would be given by the AWS. As soon as the GitHub Actions logs into AWS, it would be given this role. This role should have all the access that it needs to do the actions it's supposed to do. Say in my workflow, I want to create a EC2 instance. I want to access the S3 for putting my Terraform state. And I also want to push my Docker image to the EC2 container registry. So I have added those permissions here. As you can see here, there is the EC2 container registry, EC2, S3, and that's the instance profile for Terraform to be able to use the Terraform. So all these permissions together will give GitHub Actions all the access that it needs to log into AWS and do all the actions. So once all these steps are done here, the next thing that you would do is to create the actual workflow. So I would go into my repository here. I have a .github/workflows folder, and I have a YAML file here. This is the actual workflow that we are going to run here. This is the whole CI/CD pipeline. It has a name here, and we are saying when do you want to run it. I want to run it only on the main branch, and I want to run it on push on main branch. I also want to run it on pull request, but we will not look into that right now. Let's just think about we're going to run it when there's a push on main branch. And these are the permissions like ID token it gets to connect to the AWS. It can read the contents of the checkout and everything. What is the AWS region that you want to access, all those. And then comes the important part. Then we will define the jobs. So we have one job here called Docker creation, which is going to check out my code, go through the application code, and it's going to create a Docker image. That is the first step here. So we do inside each job, we have steps. First step is git checkout. It uses a standard action called checkout at version 3. This is an action given by GitHub itself. It's a whole script. You don't have to do anything, just use this and give actions checkout. It will do the checkout by itself. So you don't have to write any script for doing that. So it checks out the code, then you configure the AWS credentials, then you log into ECR. Then finally it's going to build the code and going to push it to the Amazon ECR. So inside job, we see that there are steps. Each step will do something. One step is checking out code. Second step is configuring the AWS credentials. Then we log into ECR. Then finally, we are going to build the code. Building the code is basically just a shell script here. We have the variables set here. Is your registry, repository. What is the tag we want? It's going to build that repository. It's going to build using that variable name that's there. And it's going to tag it and push it. So it will push. So there is one job here called Docker creation. It went through number of steps. It finally created the Docker image and it pushed into a ECR registry. That's what it has done. So it has completed the CI part. Then we are going to the infra as code part, where is CD part. So in CD part, there are two steps. One is the job called deploy, which is going to run some Terraform script here. So inside this, we have steps like, again, we do git checkout because my Terraform file is also in the same folder, same repo. Again, we configure the AWS credentials, then set up Terraform. This will do what is called Terraform installation of the Terraform plugin here. It's basically going to install the Terraform in that instance, in that environment where it is running. And we'll do steps like Terraform format, Terraform init, Terraform validate, Terraform plan. All these things it's going to do. And then finally, we have given one step here. If it is pull request, we want to run a pull, create some nodes for that. If it's not, it's just going to go here and do the Terraform apply. So inside the deploy job, we had number of steps like for checking out the code, then setting up Terraform, setting up AWS, and then we went through the steps that we saw earlier, like Terraform init, Terraform apply, plan, and Terraform apply. So finally, when this is completed, it's going to be able to do the Terraform apply. If you look at the Terraform apply, it's not very complicated. It has number of resources. This is a security group which is going to just open ports 3000 and SSH port for me. It's going to create a SSH key for me here. It's going to create an EC2 profile for doing the Docker pull. For creating pulling any Docker image from ECR, it requires a profile. So that's what we're creating here. And then we create the EC2 instance. We have the ID and we have the type, what shells SSH key we want to use that we are assigning here, which we created here. This key we created here and that we are going to use here. And we attach the instance profile so that it will be able to pull from the ECR. Then we attach the security group so that we are able to access the application from 3000 port. All these things we have done, and we are saying that you can take about 4 minutes for creating this. All these steps might take 4 minutes, and we are setting a user data. This user data is a concept in EC2 instance which allows you to run a bash script. It's going to run through all these steps, and what it's basically doing is that it's going to install Docker. It's going to add the Docker image access to the Ubuntu user. We are using an Ubuntu image here. And once the ECR credential helper, everything is installed, it's able to pull the Docker image. And it will always pull the image and run the Docker image. So basically, we have put these steps here so that every time the EC2 instance gets started up, this user data will run. And this user data, it's going to pull the Docker image and start running it. So in essence, whenever the EC2 instance gets created, it's going to pull the Docker image and start running it. And then we have a null resource here. Null resource is just it's a way to run scripts on either your local machine or in your remote machine. So in this case, we are in the remote machine. We are checking to see if we can connect to it. So it's just here for testing purpose. We are not really using it, but it's just a thing that we can know. So we come back here. Now we have done is that we created the EC2 instance. We pulled the Docker image, and we started running it. So there is one more step here for CD. Why we have this one more job here called pull Docker images is one main thing about Terraform is that Terraform is idempotent, which means if there is no change to the infrastructure, it's not going to really do anything. So say you have a code change, just made a code change and you are deploying in the application again. So it goes to the Terraform, compares with what's there in the instance in AWS. It says that, hey, the instance already exists. I don't need to create an instance. So it's not going to do any of the Terraform steps. So our user data is not going to run basically. So that's where we have this step here in the GitHub Actions where it's going to do a CD step, a continuous deployment step, where the only thing it's going to do is it's going to do something called an SSH action. It's going to use this public IP from the EC2, and it's going to log in there using the SSH key that we created previously, and then it's going to run this script, which is basically going to remove the existing image, pull the new image, and start running it. So basically, in summary, in this workflow, we have 3 jobs. First job is Docker creation, where it will check out the code and create a Docker image out of that. And second step was deploy, where it was going to create a EC2 instance of OS Ubuntu in the EC2 instance. And third step is pull Docker image, which was going to just SSH into the EC2 instance and pull the new Docker image. When these 3 steps would complete, it would be able to bring the new code change into the application. So let's just take 2 minutes and we will just go through one demo where we will just blindly run this step for code change. So in my case, this application is a very simple node application. I already have the instance running here. So let's say this is already application running in production, and we are just making a small code change here. Let me try to access it. So it says hello world and it has two buttons. Just that's it. It says buy 1 day or buy 4 days. That's it. So this is the application that we have running in the production, and now we are going to we got a ticket that we don't want 4 pages, 4 days. We just change it to 2 days. So we'll, as a developer, I'm making that change. So Git status shows that I have made this change. Let me add that into my local commit, and I'm going to commit this change. Maybe I have some ticket number or something that I attach to it. So once these steps are done, I can git push. So here in this case, I'm doing a push because we wrote the workflow to run every time there's a push. It also runs on pull requests and all, but that's a bigger demo, so we'll not go into that. So right now, let's imagine that we have the ability to push into production. So we push the code into production. Now let's see what's happening on the GitHub. I go into the actions and I can see that it has triggered the workflow. So we can see there are 3 jobs in the workflow: Docker creation, deploy, and pull Docker image. These 3 steps are there which it has to run. Let's give it some time to go through these steps. So when it's going to the Docker creation, it's going to that job that we saw. It's going through all the steps that are there on this Docker creation job. It will start a very low. It will try to start a remote Ubuntu virtual machine within the GitHub Actions environment, and it's going to go through all the steps that we're going to git checkout, configure, login, build and push image, all the steps it's going to do. So it has completed the Docker creation. I can check here all the steps that we have in the workflow. We can see here all the steps are completed successfully. You can see the logs here, configuring all the things we can see here. I'll go back to the summary view where it is now doing the deployment. So basically it saw that the EC2 instance is already there and I don't need to create an instance there. That's what's meant by idempotent. So it's not going to do anything. So we go directly to pull Docker image, which is going to SSH to that EC2 instance and just pull that Docker image from there.
We have an ambitious question in the chat, Manu. The question is, assuming we have a domain available in Route 53, can we also automate pointing the domain name to a deployed app via Terraform, IAC, or GitHub Actions?
As part of GitHub Actions, I have not personally, I have not checked practically, I have not done this, but I feel like this should be possible to do it. There would be a hacking way of doing it where you might have an AWS CLI and you just run some AWS commands. Or I'm not sure, but I'll have to come back to you if there is a better way of doing it using some AWS actions. So it ran through the SSH action. These are just debug commands I gave there to see where it is running. So it ran these commands. It went to the Docker, stopped the apply app, removed the application images, and just start running a new one. All these steps are not really required. You can just say Docker run itself that and Docker remove. That should be enough to run this. It's just a demo, so we have gone through many steps here. So let's see if the change is reflecting here. So we can see that the change is reflecting here. So I think as a developer, I can close this ticket. So any questions on GitHub Actions?
I think that was the only question we had.
Okay. So we saw these steps already in the AWS console, how it works. It just uses the JWT token. There will be two tokens there. It will be used to set the ID and the access, and it would get a STS. STS would apply the role to that GitHub Actions, and it would be able to use all the policy permissions that are given to that user. So we went through these steps. We set up the GitHub Actions. We did the CI. It's what it did is that the CI step in GitHub Actions, it went through and compiled and created the node application Docker file. It created the infrastructure and deployed the new Docker image to the infrastructure. And we saw that we use the Terraform to provision all the infrastructure and use the GitHub Actions to invoke the Terraform and do all the steps required in the CI/CD pipeline. That about concludes my demo. The idea here is that try to automate as much as possible in your workflow and try to achieve something closer to what is the ideal situation. I have a couple of links here. I'll be sharing this presentation with you anyways. I have my LinkedIn contact here, and I have also given the QR code for the demo code. You're free to contact me on LinkedIn if you have any other questions or you want to collaborate on anything. Thank you. I don't think I want to take more time here.
Thanks, Manu. That was a great presentation, and thanks a lot for taking time out to talk to us at AWS User Group Punjab. For those who don't know, Manu recently graduated one of the programs at AWS that's called AWS New Voices, and I'm really happy to see him taking the next step and speaking at user groups online as well. I'm sure that he'll be also talking offline next. Uh, is there any talk of offline talk which is planned for you, Manu?
Yeah, I'm looking into that. Yeah.
Awesome, cool. Again, I wanted to want to thank you, Dheeraj and Manu, for taking time out and speaking to us at AWS User Group Punjab event, and hope to see you around again soon. Thank you again.
Thank you, and glad to be here. Thank you all.